Hi, I'm Carla Westphal from Saddleback College. In this video, we're going to be taking a look at using L'Hopital's rule for an indeterminate difference. So let's just do an example here. Let's suppose I have the limit as x goes to infinity of e to the x minus x. Now, if I look at where the individual pieces go, e to the x is going off to infinity, and x is also going off to infinity. So we have, quote unquote, infinity minus infinity. Now the temptation is to say that that's zero. It's not though, because infinity just means that these things are really, really big. It doesn't mean that they're the same size. And if they're different sizes, then the difference between them is not going to be zero. And I happen to know that e to the x and x are different functions. They're not exactly the same size, so it's entirely possible that this limit is not going to be zero. So anytime we have something that leads to something that looks like it would be infinity minus infinity, we call that an indeterminate difference. Again, knowing where the individual pieces go isn't enough to tell us where the whole thing goes. The fact that this piece goes to infinity makes me think, oh, maybe I should get something big and positive. But the fact that I'm subtracting something that goes to infinity makes me think, oh, maybe I should get something that's big and negative. I need to explore things a little bit. Okay. So our indeterminate difference is, quote unquote, infinity minus infinity. Okay. Now, anytime I have an indeterminate form, I'm going to use L'Hopital's rule. But I can't use it directly, because L'Hopital's rule applies to indeterminate quotients. So I need to do some algebra to get to an indeterminate quotient before L'Hopital's rule even applies. Okay. It's not immediately obvious what we should do here, but here's what I'm going to do. I'm going to just do some factoring. I'm going to say this is the limit as x goes to infinity. And you might say, what on earth can she factor out, because these guys have nothing in common? And you're absolutely right, these guys have nothing in common. But I'm just going to pick one and factor it out. Just for kicks, I'm going to pick x. So I'm going to factor out an x. If I factor out x, I'm going to get e to the x over x minus 1. X factored out really nicely from the x. When I pull out the x, I've got a 1 left over. Didn't factor out super nicely from an e to the x, but we're okay here because we're able to say, x times e to the x over x would just give me e to the x. So if I distributed it back, I'd be right back to where I started. Okay. Now, if we look at this, now I have this product. X, that first factor, is going off to infinity. If I can figure out what this limit is, I might be able to determine the limit of the whole thing. Now, I can't actually do arithmetic with infinity. It doesn't make sense to multiply infinity by a number. It doesn't make sense to multiply infinity by infinity, but I could do an informal analysis. If it ended up, it doesn't, but if it ended up that this limit was 2, what I'd have is a product of something that's big and positive multiplied by 2. Well, that would be big and positive, and my limit would be infinity. So I can sort of use common sense to put the pieces together. But what that means is I want to do a little bit of side work so that I can figure out where this piece is going. So I'm going to say, let's look at the limit as x goes to infinity of e to the x over x minus 1. Well, here I can say this piece is going off to infinity. This piece is also going off to infinity. So for just this part, I've got an indeterminate quotient. Now, whatever I get for that part, I'm supposed to subtract 1 from. Okay. So I'm going to do a little bit more side work. I'm going to focus on just that part. The limit as x goes to infinity of e to the x over x. I can use L'Hopital's rule for just that piece. So I can say this is the limit as x goes to infinity of e to the x over 1, which is just infinity. So this fraction is going off to infinity. Now I can't perform arithmetic with infinity, so I can't literally say this is infinity minus 1. But if this piece is going to infinity, it's getting really, really big and positive. And if I subtract 1 from it, that doesn't change the fact that it's really big and positive. So this limit is also equal to infinity. Which means over here, where we had the product of x times e to the x over x minus 1, we've just determined that that piece is going to infinity. Now notice I'm being very careful to just use arrows here. I'm not writing infinity times infinity because multiplication is an arithmetic operation that's defined for numbers, and infinity is not a real number. But logical analysis here, this is big and positive. This piece is big and positive. What do I get if I multiply together two things that are both big and positive? Something that's really big and still positive. So that this limit will be infinity. All right, so there's an example of L'Hopital's rule with an indeterminate difference.